Okay, so the last
I need ELA one to report again for EOC testing. ELA one.
Yesterday we were in the locker room after weights, and Miss L like peeked her head in the locker room and was like, "You guys are being too loud." And like she was looking in the boys' locker room. Wait.
should have been quiet. Okay.
I'm naked.
We are looking at systems of inequalities. This is review for you. You did it last year with Mrs. Keller. However, I think when she covered it with you, you only did linear systems, and so we might have non-linear things as well. So we're just going to look at some problems. I printed it for you so you would have the graphs right there and make them nice and pretty. We may not do all these examples. We just kind of see what we need and we'll go from there. So when you are giving a solution to inequalities, you are not just giving an ordered pair. You are basically going to look at a graph and we are going to shade the correct solution. So then any point in that shaded region would make both true. So to do this, we have to start by graphing each of these two inequalities. Now the first one, what would you do to graph that? Yeah, if we put it in y equals mx plus b form, so that would be y less than or equal to negative x plus 2. We solve for y, so then that's a line. Y-intercept of 2, slope negative 1, so down 1 over 1. And then how do you draw the line from there? Is it solid or dashed? Do you guys remember? Solid. How do you know? Okay. So does anyone need a ruler? If you want one, I have plenty.
You care if the line is not.
I mean, do your best. Make it decent. I'm not very good at drawing straight lines up here, so. All right. Now, that's y equals negative x plus 2. We need y is less than negative x plus 2. So what do we do? Okay, pick a point. Something not on the line. 0, 0 is usually the favorite unless it falls on the line and you have to pick something else. So if you plug 0, 0 in, you get 0 is less than or equal to 2. Is that true or false?
True.
True. So 0, 0 makes it true, so that means that half of the line is shaded. I'm not going to shade it all the way yet because this isn't my final answer. So just lightly shade that in.
So can we just do what we did with lines?
For now, yeah. At the very end, we'll mark our final answer. All right. So now go to the second one. So you have to solve for y. So you have y is greater than or equal to negative 2x plus 4. So y-intercept is 4. Slope is negative 2, so down 2 over 1. Solid or dashed? Solid because it has the equal to. And now we have to figure out where to shade. So what do we do? Okay, if you put 0, 0 into that one. You can do the original or this one, doesn't matter. So we would get 0 is greater than or equal to 4. Is that true or false?
True. Oh, you're right.
So 0 is not bigger than 4. So 0, 0 does not work. So you shade the other half of the line. Now, my final answer is what?
We're both are shaded.
Yes. So it's this region right here in between those two.
We just shade that like darker?
Yes. So I need to be able to look at this and tell the overlap. So some people like to go back and erase the other shading. Some people just make that really dark. Some people get a highlighter and color it in. I don't care how you do it, but I should be able to look at it and clearly see where your overlap is. So that means any point in that black region would make both of those original inequalities true. Can I show you guys a little trick for shading?
Sure.
So if it's lines, then we can look, so this one was less than, and we shaded below the line. This one was greater than, and we shaded above the line. So if you're looking at lines, you don't necessarily have to do a test point. You can know less than's below and greater than's above. If that doesn't really click with you, plug in your test point still. Okay, that's no big deal. It doesn't take that much extra time. Just a little tidbit if it makes sense. Yes.
This is still the same if you have like a negative 2x equals 5. So still.
Yes. If you, so when you divide by a negative, you flip your inequality. And you would be basing the less than, greater than on this equation, not the original, but after you solve for y. Other questions?
What equation?
When you're looking at the less than, greater
No,
than.
I know. I should what if three equations to have
Oh.
the drop down.
Gotcha. Okay. Why don't you guys try this one? So solve each of those for y.
Why did you eat it then?
Question.
No answer.
Yeah.
I want a thick brush.
Because I left my room when my classes changed all the settings in it because they were drawing, and now I haven't taken time to change them back. Okay. So if we look at this, the first one you solve, you get y is greater than negative 1/2 x minus 3. So that's a line y-intercept negative 3, slope of 1/2, so up 1 over 2. Solid or dash? We already said dash because there's no equal to. Okay, greater than, so where would I shade?
In between. Above.
Above this little region. Or if you did a test point, if you did 0, 0, and you could put it into the original, or right here you get 0 is greater than negative 3, which is true, so you shade where 0, 0 is. For the second line, you get y is less than negative, or less than 1/2 x. So that's a y-intercept of 0, slope 1/2, so up 1 over 2. Again, dash. Okay, where would we shade? Down. Less than is below. Or if you put in 0, 0, you get 0 is less than 0. Why did that not work if I put in 0, 0? It's on the line. So when you plug in a test point, you can't do 0, 0 that time. You have to pick something not on your line. So you could do maybe 0, negative 1. And if you do that, you get negative 1 is less than 0, which is true, so we shade. So our final answer, the overlap,
Right in the middle.
everything between those two lines. Are those okay?
Yeah.
You plug in negative 1 to a half. It's gonna be negative 1.
Negative 1 is the y.
Oh.
Let's look at some more. So let's do some non-linear ones. X squared plus y squared is greater than 9. You guys know what that's going to look like?
Yeah.
Square root.
Parabola.
It's gonna be a.
Let's see. Let's try some points. If x is 0, then you would get y squared equals 9. Let's just do equals. So then you would get plus and minus 3. So when x is 0, y could be 3,
Oh, and it's a circle.
or y could be negative 3.
I remember that one.
If you plug in a 0 for your y, you get x squared equals 9. So x equals plus and minus 3. So So when y is 0, x is positive 3 or negative 3. So
Oh, but
this
it's a dashed line.
is a circle because there was no equal to its dash.
30 plus 2 makes perfect circle.
My circle.
My circle is less than ideal.
Mine kind of looks like a dumpling.
Yeah, mine's like a
Mine looks
round
like a
rhombus.
diamond.
Round
Mine's a
rhombus.
square.
How did you mess it up?
Okay,
Put corners on it.
now we need to figure out where to shade. So let's pick a test point. Could I do 0, 0?
No. Yes.
Yes. So if you put in 0, 0,
0 is greater than 9.
is 0 greater than 9?
No.
Yeah. You put a
So-
1 in front of it.
0, 0 does not work. That means we're not shading inside the circle, we're shading everything out here.
Now we draw
It looks like a sun.
Isn't it beautiful?
No.
Fine. Alright, second one. What do we do?
Grab the X.
Yep, we can get y by itself. So that's y is less than or equal to negative x plus 3. So y-intercept 3, slope negative 1, so down 1 over 1. Solid or dashed?
Solid.
Solid.
Okay, can you tell where you would shade?
Less than.
Less than is below, or if you do a test point, you get 0 is less than 3, which is true, so 0, 0 works. So we're shading. So our solution is everything under that line and outside the circle.
Oh, absolute circle. Hey.
Your shooting's really haphazard, but you can tell.
Yeah, mine is not real beautiful.
Mine's pretty.
Yeah.
Last time we
My
did
6-year-old coloring the sun.
Why did we not shade this one?
Because when we checked the test point for the circle, we tried 0, 0 and it didn't work.
Would you lightly shade it? Yeah, would you lightly shade it?
No, because it's shaded by the line, so because it was below the line, so that part's lightly shaded, but the overlap was
You have to lightly
outside.
shade.
Yeah, so lightly shade.
If you have that lightly shaded and then dark outside that.
Do we have to lightly shade?
Yes.
As long as I can tell what the final solution is, that's fine.
Okay.
Alright. Let's try another one where something's not aligned. Yeah. Y is greater than x squared minus 4. So that's just a parabola shifted down 4. And you could put in points if you needed to. You know, if x is 0, you get negative 4. If x is 1, you get negative 3. If x is 2, you get 0. If x is negative 2, 0, negative 1, negative 3. Solid or dash?
Yeah.
Hate that.
Decide where to shade. So if you put in 0, 0, you get 0 is greater than negative 4. True or false? True. So 0, 0 works.
Inside.
So we're shading inside this parabola.
Get off me.
All right, second one. How do we graph it?
Negative 2 and then up on
Okay, and solid or dash? Less than is below, or if you do 0, 0, it doesn't work. So our solution is this little bottom part of our graph.
Mr. Coach is gonna hit a home run today.
Good.
I feel it on my
Who do
bones.
you guys play?
Louisiana.
I've always got Phil.
Why?
Alright. Let's try. I'm gonna skip to the very last one. Too late. So you're not limited to just 2 equations. So the last two examples just have multiple equations. So basically you're graphing all of them and looking for the overlap of everything. Okay.
That's an increase.
I want to do this example for sure because of this first inequality. When I say -4 is less than x is less than 0.
I think it's not.
If it's x equals a number, what kind of line is it?
Vertical.
Vertical. So it's saying you have vertical line at -4 and at 0, and you're shading in between the two. Okay, would they be solid or dashed lines?
Yeah.
So we have vertical line -4, that's dashed, and that's 0, and x is between those, so we're currently shading right there. So for this one, I have to solve for my y. So how would I graph that?
Put in point 2 and then down 1 right 1.
Solid or dash?
Dash.
It's greater than.
So we're shading above that red line. Next piece,
10.
start at 10, down 2 over 1. Solid or dash? And where are we shading with that one? Below. So it's kind of a mess, but can you tell where the overlap is?
Right, we did the other day. Back accurate.
This region. Right here.
Wait, wait.
You do the same thing as
Yeah.
Okay.
Do you want us to shade, is it where all three overlap? Okay, so it doesn't matter that they overlap at the bottom?
Right, because it wasn't all three, the first equation, so those vertical lines weren't there.
Get it, get it.
Is that okay?
E.
One last problem, then we're done?
Oh, if we go
All right.
back.
Yeah, jumping around. Alright, if I say x is greater than or equal to 0.
Vertical solid line at 0.
Okay. So that's just the y-axis, and then which side of it am I looking at?
Right,
Right side.
Yeah, x is greater than. So we're talking about everything in the first and fourth quadrants, basically.
Why? So it's gonna be the one we
Y
can
greater than 0, so a dashed line on the x-axis. And where is that one shading?
Also
Above. So currently, can you guys tell me where my overlap is? Yeah,
Right.
first quadrant. Okay, this one, that would be y is greater than or equal to negative x plus 2. Okay, solid line. Where's that one shading?
Above.
Above. So all I did right there was basically take out this little corner of the first quadrant. So currently, I'm just looking at this region. If you get confused, if you're starting to get too much stuff in your picture, you're welcome to go back and erase some of your shading. You know, you don't have to, but if it's confusing you, we are limited right now to that portion of the first quadrant. Then the last one, you will get negative y is greater than negative 2x plus 4. Divide by a negative, which flips the inequality. Y-intercept, negative 4, slope of 2. Solid or dash?
It's less than 2.
So where does less than go? Below. So what you end up with that portion of your first quadrant. Alright. Are you guys okay with this stuff?
Yeah.
So I have a handout for you.